Hello, in this video I'll talk about the drill rods and tool joint couplings. Drill rods are used to transfer torque to the drill bit and deliver drilling fluid downhole. The drill rod consists of a pipe and tool joints that connect to the ends of the pipe. The design is not different in oil and gas drilling or shallow water well drilling, but the quality requirements are different. Tool joints and the drill rods that are used in deep drilling must be manufactured strictly in accordance with the standards for these products. The standards clearly describe the manufacturing technology, dimensions, characteristics and quality control methods. In this industry, accidents are very expensive, so the emphasis is placed on maximum reliability and durability during the writing of the standard. To reduce the weight of the drill string, the pipe ends are upset. This technological operation increases the wall thickness at the ends of pipe to make a threading. The upsetting can be internal, external or combined. The drill rods that are used for drilling of shallow wells must be lightweight, so that two persons can work with them manually. Also, here are used more affordable materials to keep cost down. Drill rods are manufactured of seamless, thick-walled pipe. Drill pipe couplings are made of 3140H steel or 3140 for shallow wells. To connect the drill pipes is used a special tool joint thread. This thread is easy to center and it can be completely screwed in a few turns. It ensures the tightness of the drill string and withstands big axle and bending loads. In tool joints the thread has a tension. If you screw the coupling, you can see the thread will not fit completely. To make it fully tightened, you need to make an effort. The thread tension provides springiness and leak-proofness of the connection, and also prevents untwisting during hammer drilling. If there is no thread tension, the drill string bends during operation and here the gaps appear. The tightness is broken, the rods become overgrown with bentonite and the drill string becomes salted. This could result in the loss of the tool. Also, if the tightness is broken, the pin thread is washed out by the abrasive particles that are contained in the drilling fluid. This is especially true in deep drilling. The rods operate for a long time with a high pressure and alternating loads, namely alternating bending tensions, torsional impacts, longitudinal and cross vibrations. The amount of thread tension is calculated and spelled out in the standards. It is checked by using a gauge. There are working and control gauges. Working gauges are used for thread cutting, and control gauges are used to check working gauges for wear. Let's check the thread tension with a gauge. The first one, we take a pin. We screw the ring gauge on the pin with the effort of one person by using 150 mm level arm. Next, we measure the distance from the torque shoulder to the reference plane. The allowed value is specified in the standards. At the same time, we check the perpendicularity of the torque shoulder to the thread axis. We check the distance in several places on a circle. The allowed deviation is indicated in the standards. Now let's check the box. We screw it on the gauge and check the size from the torque shoulder to the reference plane. According to the standard, it should be 0 plus the allowed deviation. We measure in several places in a circle and check the perpendicularity of the torque shoulder to the thread axis. During drilling, the axial compressive load is transmitted through the torque shoulder. Thus, under pressure on the drill string during shocks and vibrations, the thread will not suffer. For example, if we use a drill pipe couplings without a torque shoulder, then the compressive axial loads will be distributed over the entire contact area. In this case, the thread wears out and the service life of the connections is reduced. In addition, the thread will tighten so tightly that it cannot be unscrewed. Therefore, the torque shoulder plays a very important role. Before the advent of CNC machines, tool joints were machined on lathes with an active cross slider or on a usual screw-cutting lathes by using a tapered turning attachment. The design of the threaded part was differed by the presence of a relief groove for the tool exit. The relief groove in box coupling is convenient for machining. However, as a result, we get fewer working threads, and its use is impractical at high torques. Therefore, now threading is performed only on machines with computerized numerical control. In manufacturing of the drill rod couplings, it is necessary to control a taper angle. If it is incorrect, stresses will be concentrated on the first or last threads. This will lead to premature wear and leakage and make possible loss of the drill strain. The taper angle is checked with smooth gauges before threading. On the coupling are milled slots for wrench or grooves for marking. It depends on the rig design. In small-sized drilling rigs, to unscrew the thread is used a wrench. In deep drilling is used a hydraulic gripping, and the marking grooves are used only to determine the type of the drill rod coupling. After machining is carried out volumetric hardening. Tool joints should have a hardness from 28 to 32 Rockwell units. If the coupling is soft, then occurs sticking and destruction of the thread. The connection is difficult to unscrew. Sometimes the connection cannot be unscrewed due to high loads. So the drill rod connection should be hard, but not brittle. If the hardness is too high, the thread will be chipping off on impact. Therefore, it is important that the hardness is within the limits specified by the standards. There is also a method of hardening of threaded part by induction heating with high-frequency currents. But in well drilling, volumetric hardening is more preferable, and here's why. Induction method provides a surface hardening. The depth of heating is regulated by frequency of the current, but hardness in several areas is very different. The crystal structure is heterogeneous. Internal stresses appear, and also a microcracks between the hardened and soft material. In some cases the drill rod breaks off because the threads of the pin were come off and remained in the box part. With volumetric hardening, the hardness and structure of the steel is uniform through the full body of the tool joint. Torque shoulders are not crushed by impact. The slots and the outer surface of the couplings do not wear out. To prevent cracking, all corners should be rounded. For example, a rounding corner must be made at the base of the pin thread. Also, the thread profile must have a rounded corner of the roots and crests of the thread. All corners are stress concentrators. In those places under alternating loads, cracks appears, which leads to accidents. Alternating mean loads that often choose their direction. For example, tensile due to weight of the drill strain while lifting, and compression due to pressure on the bit while drilling. Here is another example. Bending loads due to buckling of the drill string. During operation, the drill string bends in a sinusoidal shape and rotates at the same time. The direction of the bending moment is constantly changing. Due to such loads occurs fatigue failure of the metal. The microcracks appear, which increase our time. Therefore, in deep drilling, the drill rods go through a regular ultrasonic or magnetic particle inspection to detect cracks. Tool joint is connected to the pipe by means of thread or by friction welding. The threaded connection uses a tapered thread with a triangular profile. An external thread is cut on the pipe, and a mating internal thread is cut on the tail of the tool joint. The thread is screwed very tightly. It is sealed and completely reliable connection. Requirements for production technology and quality control are spelled out in the standards. Friction welding also provides a reliable connection, but only in strict adherence to technology. For friction welding are used special machines. The tool joint is inserted into the spindle gripper. The pipe is inserted into the support gripper. The spindle rotates. The support presses the pipe against the tool joint. Due to friction, the contact area heats up. Then the spindle stops quickly. The hydraulic cylinder presses the pipe with increased force and makes forging of the welded joint. The machine cuts off the flash. This is the metal squeezed out of the joint. After welding, the welded joint must be normalized to relieve stress. This operation uses an induction heating. The finished rods are tested for bending and alignment. The bend test is carried out on a bending press at 8 points around the perimeter in the welded joint zone. If the welding technology is violated or if normalization do not carried out, cracks may appear in the welded joint. Therefore, during the acceptance of a branch of drill pipes, the samples of the pipe body are cut out. They are being tested on tensile and impact bending. Destruction of samples along the welded seam is not allowed. We manufacture drill pipe couplings according to API and GOST specifications. We also manufacture seamless drill pipes with a thread connection of the tool joint. We carry out strict control of the manufacturing technology. All materials have certificates of conformity. We have different options of tool joints and drill pipes for small drilling rigs and also for deep drilling rigs. We ship orders to all countries in the world. To place an order, follow link in description or contact me by phone. I will calculate the cost of order and deliver it to your country. Write your questions below in the comments. I will give a detailed answer. If this video was useful for you, please like and subscribe to my channel. Good luck. Bye.